Hi there, welcome back to Data Science Castnet. I haven't posted in a little while, partly because I've been thoroughly distracted generating a whole bunch of art. And so in this video I'd like to give a bit of an overview of some of the tools that I've been exploring, as well as just a bit of an explanation for how I made all of this. There's going to be timestamps in the description along with links to further resources, so if you're here for something specific, that's the place to go. Otherwise, let's dive in. So the thing that got me to take a renewed interest in all of this was an explosion of art on Twitter and elsewhere, generated using some combination of Clip by OpenAI and a generative model like Big GAN or later VQGAN. So luckily some people had worked on notebooks that made it really easy to dive in and get started playing with these systems, which I've linked below. But to really understand how they work, we're going to have to look kind of one component at a time. So let's start with Clip. Clip is a model trained by OpenAI with the purpose of associating images and text. It can do other things, but the idea is that given an image or text, it kind of maps both to the same sort of space. And then it can measure similarity by just calculating the distance in this sort of hypothetical space. So for example, you might have an image caption that says a photo of a teapot on a table, and then the image itself also gets encoded, and by comparing those two, the goal is to have an accurate caption image pair be very similar and an inaccurate one be very dissimilar. So this is super useful for tasks like image retrieval, but it also gives us kind of a way to measure how well any image matches a text prompt, and this is going to be useful when it comes to generating images to try and match a prompt. Clip forms the first half of the system, but we still need something to do the actual generation. There's been some recent experiments with diffusion models for this, but the more established method is to use a generative network, or GAN, most popular being Big GAN or VQGAN. So these networks have been trained to generate realistic looking images based on whatever data they've been shown. And the idea is that we can take an image and we can encode it into a much smaller feature space, which we call Z, where this image becomes a point in the latent space of the GAN, which is represented by this vector Z. And then we can take that and decode it back into an image which hopefully looks superficially like the input image. This is useful for multiple things. You may have seen sites like thispersondoesnotexist.com where they've just sampled random points within the latent space that generate realistic looking faces that don't correspond to actual human beings. We can also use this to interpolate between images by encoding both and then interpolating between the different vectors in Z space and generating image outputs for intermediate points. We can get kind of a smooth morph between two images. It doesn't always work too well, but when it does, it's quite impressive. But in our case, what we're wanting to do instead is use these to generate images that match a prompt. So the way it all comes together is we start with a Z, right? We start with vector Z, which we can get it from an initial image, or we can just use noise. And we're going to use that to generate an image and then feed that image through Clip to generate a loss, right? How badly does this image that we just generated match some target text, which is the description of what we want to generate. And the nice thing is this whole pipeline is differentiable. So when we get our loss, we can then go back and say, how do we update Z, right? Using whatever optimizer we want. How do we update Z to get something that does better? And so iteratively over time, we go from essentially just noise, which doesn't fit the prompt very well, to something that does. It's to something that, at least to Clip, looks very much like the text description. And so there's all sorts of nuances to this. There's tricks for making it more robust, like comparing multiple different subsections of the image against the prompt. But in general, this is the core idea, right? We're using Clip to guide the generation process and to find some input Z and sometimes some other parameters as well that will generate an image that best matches that prompt. So this is the approach that I've been using to generate all these images. For something like the Postcard Earth project, the prompts were things like a postcard from Australia that is stereotypically Australian. And so then the GAN is trying to generate images, and Clip is evaluating them against that text prompt, and it ends up with something that looks, at least to me, stereotypically Australian. And so this was used for various regions around the world, and it's quite fun to see kind of a glimpse into the model's mind, right? Like, what is its optimized representation of a place? It's not perfect and it's not the ultimate representation. It's just one representation that kind of maximizes that reward or minimizes that loss that we've defined. So that's really cool, but you might have seen that a lot of the pieces I showed were animated or moving somehow. So how do we go from this system for generating static images to one that generates moving images? The answer is not that complicated, actually. Because we can re-encode an image back to get a new Z, we can do the refinement process over and over, but in between steps we can apply some transform and re-encode it back. To put it another way, we generate an image, then we zoom in on that image, we re-encode the zoomed portion, and we start the process again. And by doing this with zooms or shifts or pans, we can create these sort of moving pieces, and as the image is transformed and morphed, the model then has to find new outputs that still satisfy that prompt as closely as possible. And this can be really trippy, and it's one of my sort of favorite things to explore in this space. More recently, I've also been asking the question, can I drive this with video? And this is something where there aren't too many existing tools, but the approach that I took there was to say, okay, not only now do we need to generate something that matches the text prompt, we also want it to kind of structurally resemble some driving video, right? So we're going to use the frames from an existing video to kind of animate the process. So to accomplish this, what I do is I take the loss, which is just how well the generated image matches the prompt, and we add a second component to that, which I'm going to be calling content loss, right? This is some measure of perceptual similarity or structural similarity. How well does our output image match the overall arrangement and structure of the driving video? And so to do this, I lent on a fairly classic architecture, VGG16, and borrowed some code off GIST to implement something called perceptual loss, and specifically like a structural loss, which I'll call the content loss. So now when we generate an image from some starting Z, and then we calculate not only the loss with clip, how well does it match the text, but the content loss, how well does it structurally resemble the video. And we use both of those losses together to then optimize Z into a position that kind of minimizes the combination of the two. So this works decently. Further refinements include adding convolution with a filter to highlight edges and emphasize edges while leaving sort of less penalization for different colors if you want more sort of stylistic freedom. And then also just making small tweaks to how many iterations we do for each frame of the driving video and how that's all combined and synced together, and some post-processing to kind of reduce flicker. So it took quite a bit of work and experimentation to get this going, but I'm fairly happy with the result, and I think it's just going to keep getting better as everyone kind of comes together and tries out the code and figures out improvements and ways to get that working even more smoothly. So that's a kind of overview of everything I've been playing with. There's lots more little side quests that everyone's getting involved in. I highly recommend trying out some of the starter notebooks and then seeing what directions you would like to take it. Also check out what other people are doing artistically, because it's one thing to just generate an image, it's entirely another to curate and steer and morph and adjust and post-process those images into something that actually is meaningful. So check out what some of the artists are doing in this space. For the rest of this video, I'm going to leave you with a bit of audio and kind of a collage of some of my favorite things that I've generated so far. If you have questions about any of this, do leave them in the comments. Otherwise, have a good time and please share what you make. Cheers for now.